In just 40 days, an object from another star will glide by our planet. For the first time in history, we will be able to witness it in real time. When I initially calculated the trajectory of 3 Atlas, I was taken aback by how ordinary it appeared, at least until it started to reveal its true nature. This celestial object, measuring roughly 5 kilometers across, follows a trajectory that crosses the solar plane like a silent traveler without a home star to return to. It is now speeding toward its closest approach to Earth, scheduled for December 19, 2025, at a safe distance of 167 million miles away. Far outside any danger zone, yet near enough for humanity to capture its most intimate glimpse of a visitor from interstellar space. Each day leading up to this event presents an opportunity for discovery, a countdown, not to a collision, but to an understanding. We find ourselves on the cusp of the final phase of a cosmic endeavor that has spanned 8 years, one that could answer questions posed since the original passage of Oumuamua in 2017. What causes these objects to accelerate without visible means of propulsion? Why do they emit spectra that defy our comet models? And why do they consistently appear when we least anticipate them? This narrative extends beyond just 3 Atlas. It encompasses how we interpret the universe when it presents us with a riddle. As of today, 3 Atlas has completed its perihelion pass, reaching its nearest point to the Sun around October 29th. One would anticipate a comet to erupt dramatically and then diminish in brightness. Instead, it became 5 times more luminous, shifting in color from amber to cyan. From our vantage point on Earth, it temporarily disappeared behind the Sun, unseen for days, only to re-emerge bluer than before. Observatories in Spain, Hawaii, and Chile once again detected its signal. The spectra revealed ionized carbon, oxygen, and an additional element indicating a reflective signature that points to a smooth material, rather than mere dust. If this were a conventional comet, we would expect it to display a lengthy red tail. Instead, images from Tianwen-1 and ESA's solar orbiter reveal an unusually compact core with nearly no tail whatsoever. So, what is this object doing out there? The most plausible natural explanation is the outgassing of unusual volatiles, possibly CO or CO2 released as the Sun warms the surface. However, the numbers present a challenge. To account for the observed acceleration, it would need to expel tens of millions of tons of material, enough to surround it in a dense dust cloud, which we do not observe. This indicates that the force we are witnessing, whatever it may be, is subtle, sustained, and likely not typical evaporation. For the first time in our history, multiple worlds are tracking a visitor from beyond the stars, including Mars' orbit. China's Tianwen-1 transmitted a series of images capturing a bright, spherical entity floating against the darkness. Back on Earth, the European Southern Observatory and NASA's Deep Space Network began logging polarimetric data to measure how the object's surface twists incoming light. Additionally, the Indian Space Research Organization has also engaged, coordinating radio measurements using its S-band network. In Cambridge, our Galileo project has integrated these feeds into a shared database. What emerged is a consistent pattern across various instruments and nations. The object has a rotation period of 8.66 hours, presenting a remarkably flat phase curve unlike any known comet. And its color index remains stable at about 0.35, similar to polished nickel. Nickel is an uncommon surface material for interstellar bodies, suggesting either metallic inclusions or a dense refractory crust developed over centuries of cosmic radiation. However, a more provocative possibility exists, one I mention with caution. It could be a manufactured alloy, potentially a fragment of something larger. While the data does not definitively prove this, it certainly invites curiosity. When Congresswoman Anna Paulina Luna inquired with NASA about the unshared high-resolution images, I felt encouraged. Science needs advocates beyond its confines. Her simple letter poses the question, why should the public be kept waiting for data belonging to humanity? Rather than responding to her office, NASA opted to reply to a celebrity's tweet. That moment became emblematic, illustrating the disparity between bureaucracy and curiosity. While I have no issues with Kim Kardashian asking questions, I do find it concerning that the agency addressed her before the scientists. This situation, while somewhat amusing, carries a hint of sadness. Transparency is the lifeblood of science. Without it, we suffocate in speculation. Thankfully, the global community did not stall. The ISRO, CNSA, and JAXA all released their frames into the public domain. Together, these contributions create a mosaic of knowledge that no single agency could accomplish alone. The takeaway is unmistakable. The universe belongs to anyone willing to explore it. As 3 Atlas approaches on December 19th, it will shine not for any single nation, but for all humanity. So, what can we expect on that day? If our models hold true, 3 Atlas will cross Earth's orbital plane just before midnight UTC on December 19th, reaching a magnitude of +10. It will be faint, yet observable through mid-range telescopes. Its spectrum should indicate whether the blue light originates from ionized gas or metallic reflection. Ground arrays will monitor for radio emissions in the 13 GHz band, while polarization sensors will look for any unusual electron alignment around it. If it behaves like a comet, we should observe an increase in outgassing and a reduction in velocity as it moves away from the Sun. Conversely, if its trajectory remains smooth, controlled, and its brightness unchanged, we will again face the questions first posed by Oumuamua. Is there a mechanism we do not yet understand? Or is there a creator we have yet to recognize? Both answers are astounding. If the phenomenon is natural, it implies there are subtleties in the laws of physics we have not yet grasped. If technological, it suggests we are not the first engineers to traverse the stars. Either scenario broadens the narrative of humanity. When people ask me, "Professor Loeb, do you believe it's aliens?" I respond, I trust in evidence. Belief is subjective, but evidence is collective. The elegance of science lies in its ability to transform mystery into measurable understanding. However, to measure something novel, we must first be open to the possibility that our former assumptions might be flawed. I frequently remind students that our species has only been observing the cosmos through telescopes for 4 centuries, while the universe has existed for approximately 13 billion years. A minuscule sample size. Therefore, humility is not a weakness. It's a necessity for accuracy. December 19th grants us an opportunity to embrace that humility, to observe the sky impartially, and to allow data to guide us before theoretical assumptions take hold. If we discern nothing unusual, we still gain insight. If we stumble upon something unexpected, our understanding deepens exponentially. In either case, the universe emerges victorious. In 40 days, a guest from another star will traverse our planet softly, gracefully, perhaps forever, and we will be watching. There's a certain beauty in this idea. Across continents and cultures, millions of observers will focus on the same tiny segment of the sky. From the Atacama Desert to Beijing, from the JWST to small backyard telescopes, humanity will be united by light that has traveled from an object born among the stars. Some will seek evidence of alien technology, while others will look for proof of natural phenomena lying beyond our current comprehension. I, however, will search for something more fundamental. Truth. Truth is indifferent to our desires. It exists whether or not we believe in it. On December 19th, that truth will glide past our planet at a velocity of 87 kilometers per second, enveloped in silence and sunlight. When future generations inquire about how we responded to our first opportunity to study such an immense interstellar object up close, I hope the answer reflects our attentiveness. Until that moment, the countdown persists. Every night as 3 Atlas inches closer, it serves as a reminder of what we are truly part of. A species sufficiently curious to question and bold enough to explore. Science begins with wonder, not with certainty. And on that day, beneath the tranquil winter sky of December 19th, wonder will speak for itself.